So good afternoon, everybody, and thank you for the introduction and the warm welcome. And thank you also to the previous presenters, because it's been a fantastic setup for what I hope is some insight into how some other technologies we've been working with can help knit together some of these opportunities and provide some useful tooling. So as Jason mentioned, we're a new company. We've been running for about just over a year properly. Spinning out from Transport Systems Catapult. We were based in that little room over there until very recently, and expanding fast and applying some of these new technologies to transport and mobility problems. My background is engineering, so I guess in the oil analogy, I'm used to trying to work with the machinery to do something useful with it. I value oil quite a lot, but it needs to be turned to a useful, productive purpose. So what are we doing? So the company is about simulation. So data is very important to us, but that's the starting point for a lot of what we do. So we've heard quite a bit about all these new sources of data that are becoming available, that can be used, that have got issues with them. We'll talk about that a little bit in a minute. But really what we want to do is turn that oil, bring it into our engines, our machinery, and then use those engines to try and deliver mobility, in our case, to try and deliver productive outputs. So we've been applying some of this tech, and we can talk about it in more detail. The last point I'll come back to towards the end, but there isn't a single organization in here that can solve this problem on their own. So you've heard about that in some of the earlier sessions around mobility as a service, but delivering on the potential of these data sets and the potential of these transport innovations requires us to work together, and we need to find good ways to do that. So I mentioned data and some of the sources and some of the opportunities. So this is a sort of illustration of some of the sources. So we have people in the background. I think Robert mentioned it particularly. Fundamentally, it's about us. It's peoples and systems and mobility in order to get ourselves and get things to the right places, to get them where we want them. We've got mapping data that tells us about physical infrastructure. We've got increasingly Internet of Things data, so smart bits of kit that tell us about how things perform. We've got instrumented vehicles and fleets telling us about where they are, telematics data, and I think we're going to hear a bit more about that in a minute. We've got app data that we're all generating when we do things. We've got passively sensed mobile network data, which is really powerful for telling us about general trends. We've got social media, what we tell the world about what we each want to do. Enterprise resource tools, schedules, calendars. What is our company doing? How are we trying to achieve our objectives? And that's all being produced continually in lots and lots of different fragments in different silos. There's huge volumes of it. The techniques to do things with it are improving. It's automating. It's getting better. I absolutely love data. It's a brilliant, brilliant thing. But it isn't enough on its own. I want to talk about some of the applications where we're trying to use this to feed into some of the exciting opportunities and challenges about future mobility systems, and then come back to this idea about the new oil and how we collectively make best use of it. So, useful. Data is really, really useful. It's actually essential. I mean, we find it very hard to make inference about the future or understand what's going on around us without sensing, without measuring something, without getting some kind of data. But there are a lot of limitations, and it's really important to be aware of these. Lawrence has done a fantastic job of explaining some of the limitations of the methods. Data is also really fragmented. It sits in lots of different silos down at the bottom left. So different data owners, different experts who've put together their own piece of the puzzle, but doesn't integrate with anything else. Sometimes people make it available. You can license access to data. You can buy a subscription. You can get hold of it in a particular format. That also often places restrictions on what you can do with it, who you can work with, and how you do things. There are huge open data initiatives, and there are others speaking yesterday who are a much better place to talk about that than me. There are a lot of gaps. The middle bit is about an incomplete folder. Even the best, most comprehensive data sets are very rarely complete. There are errors in them, there are gaps, there are holes, there are biases, there are elements that mean if we automate our analysis of it, we can get really, really misleading conclusions. and we have to be aware of that. And this part at the top is about the process of working with it. So we've got some great machine learning techniques now. We've got much better methods of doing processing and interpretation automatically. But there are a lot of issues still. And very rarely does one method work on its own. So that system of how you piece together these fragmented, siloed, incomplete, varying permission data sets and do something useful with them that you can trust is a really big problem. But it's an exciting opportunity to try and solve. The key element of it is how do we use this to ask and answer useful questions. So what happened? Data's quite good at telling us what happened. What might happen next, or what should we do about it? We can infer from it. If we're in our zone of knowledge, we're probably okay. If something's changed, something systematic is different, if you've got autonomous vehicles, if you're changing the way mobility systems work, smartphones, how we all live our lives, it's changed a lot, even over our lifetimes. We can't necessarily predict with confidence what's going to happen. So we need to test things. We need to run lots of different scenarios, lots of different test cases. And we need to inform that with the best data that we can, but be recognizing that there are gaps and there are issues. So I want to talk a little bit about what we're doing in some collaborative R&D projects with partners to look at how these data-driven opportunities apply to problems like connected autonomous vehicles. So this is a program that kicked off a year ago. So if any of you were here at Imagine last year, there was a previous version of all of this where we were just starting out on the exciting journey that we're on now, where we were launching a project, where we were working with Cubic, who have great insights. You heard from Andy earlier on about the mobility as a service opportunities, but the data sets and the system insights that come from running really big transport systems. Us, leading this consortium, where we're building tools to ask what if. What if something changes? How do you test it? How do you know something about the future and understand which way you might want to go? And then working with a company some of you may have heard of called Improbable, who are a computer gaming company originally, who built some technology to create persistent virtual worlds, to try and build a replica of the real world that you can use for games, for entertainment. And in some of the work that we've done with them and through work with the Transport Systems Catapult, how can you apply that technology in real-world serious applications? And it's been very exciting, and they've just announced an improbably large fundraising of about $500 million. So there's a lot in this. We've been working to try and apply it to the problem of connected autonomous vehicle fleets, not machine learning on a vehicle to avoid hitting things, but tools that help you understand how to use that technology to service mobility. Where do the vehicles go? What should they do when they don't have a vehicle on board, driver on board? How do you recharge them? How do you ensure that you have enough infrastructure available to recharge your fleet? Can you use those vehicles for something else when they're not needed for transporting trips? Those sorts of questions. So it's easier if I show you. So this is a video of some of the tools that are running live downstairs, and you can see on our stand. Zooming in, we have map data. So this is data sets that we can all use and we all use every day. We've got data about public transit. So this is stops, schedules, even real-time feeds of delays, arrival times. We've got information about population. So this is neighborhood types categorized by demographic information. This is some data around demand, travel demand. So origins and destinations by zone. So similar to the sort of thing you can drive from a mobile network data set. We can also then infer trips. So we build up schedules. We build up a picture of how people's lives work, where they're trying to get from origins to destinations. We can then start to predict. This is a 10-minute forward projection of where we anticipate demand hotspots, which can be quite useful. So here's a relatively simple scenario. It's two competing taxi fleets running in Milton Keynes out there. The grey fleet is opportunistic. It drives around, it listens out for calls, it follows up, picks up a passenger. The orange fleet is using some of these simulation techniques. So it's understanding the travel times, the current travel times around the network. It's understanding predictions of where demand is going to be so that it can be in the right place and it can be efficient about getting there. And start seeing something flashing up. In the background, we're also looking at how those vehicles are allocated. So how do they map to trips? What's the status of the trip for the person? What's the status of the vehicles? How long are they going to take to recharge? Do they need to go back to base to recharge? What's their range remaining? That sort of thing. And it starts to get quite complicated when you build it up. And this is still the same relatively simple scenario, but now it's raining. So the demand's changed. And so the fleet that can anticipate that has made more vehicles available. It's starting to respond to being in the right place, and it ultimately ends up being more profitable, collecting a larger share of trips. And so that's just an illustration, but that's us trying to draw together open data sets, working with data providers, building them into a representation of the world, and then being able to ask questions, lots and lots of different questions that start getting far more complicated than that simple example. And I guess to summarize, data is essential to this. It is the oil that's driving this sort of revolution, but oil on its own is not particularly useful. You have to refine it, you have to clean it up. You have to have machines that can process it. You have engines. You actually want to use those engines for something. You want to power vehicles. You want to move fleets around, do something in a transport context. The analytics tools today, in my opinion, on their own aren't enough. I think that's probably a good point to pick up on in discussion. They're really powerful, but they have big gaps. So if you don't have the data in your training set, you're extrapolating, you're to some extent guessing. The last point is that none of us have got the whole answer. I mentioned that at the beginning, but we have to have business models, we have to have approaches that enable sharing and enable us to get the collective benefit of working with these different fragments, these different sections of the data to drive better policy making, better decision making, better operational transport delivery. So that's all I have. Thank you. We have a stand downstairs as well. We'd be really delighted to talk to you, understand how we might be able to work together in applying these techniques more widely. Thanks.